So, things for recognition. First of all, before I'd even start on this one, we were getting used to the idea that we have a square root. In order to do the derivative of that, we'll change things to have rational exponents. So before I even get started, I just take a look at my function and I see what's happening. First of all, I see that I have a multiplication here, and I have one function which I've underlined here in red, and another function which I've underlined here in blue. So it looks like we might need to use our product rule. But when I look at the two functions that are multiplied together, the x cubed, the first function, is an easy function to do the derivative of, but the function that's underlined in blue, can you see that it has a chain rule? That there's a function inside of the power rule. So whenever we do the derivative of the blue one, we're going to have to think we have to do the chain rule. So if we're thinking about our product rule, again, we have to have our definition memorized from the product rule. Our product rule says to do the derivative, keep one the same, do the derivative of the other one, then add, keep the other one the same, and do the derivative of the first one. So which one you keep the same first really doesn't matter. Whichever way helps you memorize best. But if I keep the x cubed the same, then I need to multiply that by the derivative of the blue one. The derivative of the blue one will be, well, it's a chain rule. I'll bring the 1/2 out in front. 1/2 comes out in front. Subtract 1 from the exponents, and then multiply by the derivative of the inside. The derivative of the inside is -3. Then add, keep the other one the same, and multiply by the derivative of the first one. (3x²). So to highlight things, we have one function here, a second function here. We kept our one function the same right there, and then multiplied by the derivative of the second function. Then we kept our second function the same right there, and multiplied by the derivative of the first one. So you have to know your product rule, and then within your product rule, you have a chain rule. And then the fun stuff comes in this part, because when you flip to the back of the book to check your answers, they will never look the same as the first step. So you have some algebra to do. You'll have some algebra to rearrange this. This one, if I would guess what they would do, they'd probably put this 7 minus 3x as a square root on the bottom. And then they would combine it as a single fraction. So you're going to get a lot of good algebra experience with the homework in this section. And on your quiz on Wednesday, all of the questions that I have like this, I will tell you what I want the final answer to look like. So you will have to rearrange it on your quiz as well. So first of all, I see the square root. And we have a function on the top and a function on the bottom. The function on the top is a chain rule, because there's a function inside of a function. The function on the bottom is a chain rule, because there's a function inside of a function. And we have our quotient rule, because we have a function divided by a function. So we go by doing our chain rule. We start by doing our quotient rule. Our quotient rule says And again, this is why you have to have these things memorized. Quotient rule says keep the bottom function the same. 1 minus 8x squared cubed. Multiply that by the derivative of our top function. Our top function is a 5x to the half. How do we do the derivative of that? The half would come out in front. Keep the inside the same. Subtract 1 from the exponent. And then multiply by the derivative of the inside function. Then we subtract. Now we keep the top function the same and multiply by the derivative of the bottom function. The bottom function is a chain rule. The 3 would come out in front. Keep the inside the same. Subtract 1 from the exponent. Then multiply by the derivative of the inside. All over the bottom squared. Let's look at our functions. Quotient rule is when you have one function on the top, that's in yellow, divided by another function on the bottom, that's in green. The quotient rule says keep the bottom one the same. You see we have that right here. Then we multiply by the derivative of the top one. The derivative of the top one is a chain rule. So the half comes in front, subtract 1 from the exponent, keep the inside the same, multiply by the derivative of the inside. Good. Then we subtract, and now we keep the top one, there it is, keep that one the same, and multiply by the derivative of the bottom one. The bottom one is a chain rule as well. So the 3 comes out in front, subtract 1 from the exponent, keep the inside the same, and then multiply by the derivative of the inside, which would be negative 16x. All divided by the bottom one. Here's the bottom one squared. Now, I cheated a little bit and did that all at once, but does it make sense that when you square something that's cubed, you get to the power 6? So I did that all at once. I could have temporarily written the 3 and then put big square brackets and squared it after. But I think you're able to say that's the same as having the power 6 there to begin with. So then, this is if you wouldn't have to simplify it. But to give you an idea of what your textbook is going to do in a question like this, and when I give you a quiz, what I'm going to expect you to do, because I'm going to give you a simplified version of the answer and ask you to get your answer to look similar to it. So what we're going to do here is notice that in the top we basically have 2 big things subtracted from each other. This first big thing subtract this big thing, all over 1 minus 8x squared to the power 6. Can you see in the top you have 1 minus 8x squareds in both this first term and this second term? I'll underline them here in red. I've got a 1 minus 8x squared cubed there, and I have a 1 minus 8x squared squared there. So when we notice that both of those 1 minus 8x squares are in each of those terms, that means we can factor them out. How many can we factor out? We can factor out 2 of them. I'm going to put a big bracket here. I'm already noticing that I'm going to run out of space here. So let's move things over a little bit. There we go. If I factor that 1 minus 8x squared out of both of those terms, in the first term, can you see that I would still have 1 minus 8x squared? I would still have multiplied by my 1/2 5x to the negative 1/2 times 5 minus 5x to the positive 1/2 times by 3 times by negative 16x. I did. Thank you. And since we took 2 of those out, this is all over 1 minus 8x squared to the 6. So I'm getting ahead of myself there. That means that these ones are going to cancel out with 2 of those on the bottom, leaving you with a 1 minus 8x squared to the 4. So that'll be part of the way that this one will be simplified. Finding a tangent line when x is equal to 3, yes, would be somewhat, but possible. You just have to plug it in. Okay, more likely I'd give you a number like find the tangent line when x is equal to 0, because that's easier to plug in all the way along. But unfortunately, this one's undefined when x equals 0, so I'd probably give you 2,543. So this is one thing that we could do to simplify this one. Another thing that you could factor out of the top is some other algebra skills that we could look at. Is there anything else in common in the first one and the second one? There's a 5, yes? And what I'm going to take out is I'm also going to take out an x to the negative 1/2 to see what that does. That will leave me here with my 1 minus 8x squared and my 1/2, because that 5x to the negative 1/2 and the 5 are brought out. Oops, sorry, I want to put this in brackets. 5x to the negative 1/2 taken out. Did I forget brackets? Yes, I did right here, right? Okay. What happens when I take a 5x to the negative 1/2 out of a 5x to the half? I'm going to be left with a 5x to the 1. You'll have to write that one. Well, you don't have to write the little one, but you do have to write the 5x. Okay? We still have a 3, and we're still going to have the negative 16x. And I wrote this at the front. What did I take out? I took out a 5x to the negative 1/2. I didn't take out the extra 5 because there was no extra 5 in my second one. Do you see that? So I'm going to have to re-add the 5 in the first one there. Make that nicer. Times by 5, and there's a subtract. And this is still going to be all over 1 minus 8x squared to the power 4 now, because we've simplified that. Yes? Often in your answer key, you'll find out that they write things like this. So if they had that square root of 5x on the bottom, you say, where did that come from? Well, when I have that 5x to the negative 1/2 out in front, that negative 1/2 moves it down to the bottom of our fraction, which makes it 5x to the 1/2, which is another way of writing square root. So if I ask you to show your final answer to look like this, then that's what you would have to do. Now, most likely in this question, the top would all be multiplied out further. There would be no additional fraction in the top. So you would have to figure out, how do I get rid of this fraction on the top so that I don't have a fraction on the top? That will be there as well, and you'd manipulate it further. Yes. All right, so here's to show that question. just to see if you're following, getting the first step right, here is your derivative with the quotient rule and the chain rule combined. So that would be our first step. Can we do the quotient rule with the chain rule? Is our derivative correct at this state? And then we're going to have to manipulate from there to make it look like we want it to. So I saw most of you do a great job next noticing that there was a 2x squared minus 5x to the power of 3 in both of those terms. That can get factored out in front. At the same time, I also noticed that there was a 3 in common in both of these terms and an x to the 6 in common in both of those terms. So I took that out as well. Some of you did that in a next step. That's fine, and you don't have to do them always in this order. But I looked for all my common factors first, and I pulled them all out. Now with the to the power 3 and the power 8, those are going to simplify, and I'll just be left with 2x squared minus 5x to the power 5 on the bottom. And I still have the 3x to the 6th on the top. What I decided to do was multiply what I had left on the inside of those brackets to see if I could combine some like terms. Maybe it would simplify further. This is just a practice one. Now I do have some like terms there, the 14x squared and the minus 16x squared. The negative 35x and the 20x, I put those together. That simplifies to minus 2x squared minus 15x. I'm getting a sense that I'm getting really close to my answer now. I notice inside those square brackets that both of those have a common variable of x. So I can pull out another x as a common factor. I also notice I can pull out a negative. And when I pull out the negative and the other x, I get what I'm trying to make my function look like. And so now I'm done. Only 4 marks. Could be more. All right, so for a first step, we first have to deal with that cube root of 1 over x. Cube root is to power 1/3. A 1 over x is same as x to the minus 1. So that cube root of 1 over x, once we manipulate it, becomes an x to the negative 1/3. So that's sort of a preliminary step to get things into a form that's going to help us do the derivative. Now we have a product rule. I put a little green dot in there to show where our first function is multiplied by our second function. So our product rule would say, keep the first one the same. Multiply by the derivative of the second one. Bring the negative 1/3 in front, subtract 1 from the exponent. No chain rule involved in doing the derivative of the second one. Then we add, keep the second one the same. The derivative of the first one is a chain rule because we have a function inside of a function. So the 4 comes out in front, subtract 1 from the exponent, keep the inside the same, and then multiply by the derivative of the inside. And there we have our entire derivative. Okay, you wanted to see what that function looked like. There it is. It looks like a cubic kind of function that had some spazzes in between there. And if you want to see what, we found the derivative. If you want to see what that looks like, we can drag this point along here. And, ooh, that is what our derivative function looks like. Draw that all in there. There we go. That looks kind of pretty. You know what that is? It's werewolf fangs. This is the werewolf fang function. Here's our next function. So first of all, did you take the 1 minus 2x and change it to a half? And then here is our product. Function 1 is just x. Function 2 is that 1 minus 2x to the half. So part of what you're practicing is just recognizing where is my first function multiplied by my second function. Then we keep one the same, do the derivative of the second one. The second one is a chain rule. The 1/2 comes in front. Subtract 1 from the exponent. The derivative of the inside is -2. And we add, keep the second one the same. The derivative of x is just 1. Then if we simplify it a little bit, the 2's would cancel out. You'd have a -x. This 1 minus 2x to the -1/2 would be like having the square root of 1 minus 2x in your denominator. And the second one would be like having the square root of 1 minus 2x as a square root in the top. At x equals -4, plug in -4. You're going to get 4 on the top of the fraction. When you plug in -4 there, the square root of 9, so you get 3. So you get 4/3 plus 3, and it's equal to 13/3.